Greetings Year 11, welcome back to another exciting class on differentiation. Today we're going to be looking at the chain rule, which is sometimes called the function of a function rule, or sometimes it's called the composite function rule or composite function rule. So let's get into the process here. Now, I need to be upfront and tell you the way we're going to start doing it is the way some people like it done. We're going to shortcut it, but for the start, we're going to look at this and go, this is the rule that we need to use. To find the derivative, dy over dx, we find dy du and then times it by du dx. Because if you look at that, hopefully you can see the du's cancel and it's the same as dy over dx. So let's actually look at this and break it down. So I'm going to say y equals 3x take 2 to the power of 5. I can't differentiate this because there's a bracket that's to the power of 5, and I really don't want to write the bracket out 5 times and go through the FOIL and expanding process. That's very time consuming. So what I'm going to do is I'm going to come across here and I'm going to say let u equal the bit inside the bracket. Now if I let u equal the bit inside the bracket, I can come over here and I can say, let's differentiate u with respect to x. What's the derivative of u with respect to x? So let's differentiate this, and the derivative of 3x is just 3, and the derivative of minus 2 drops out. So there's du dx. Now also, that means if I let u be 3x take 2, this now instead of saying 3x take 2 could say u to the power of 5. And I could then say, well, I can differentiate that, but there's no x's there, so I'm going to differentiate using the letter u. And the power above the u is a 5, so times it out the front, you get 5u to the power of 4. Now I'm going to use the formula that was written at the top of the screen. So I have dy over dx equals dy over du times du over dx. Now dy over du, I know that, that's 5u to the power of 4. Du over dx, I know that, that's 3. That equals 15 u to the power of 4. But there were no u's in the original question. Here it is, there's the original question. There are no u's in it. So I need to return it back to its x values. So that will actually equal 15. What is u? Well, we know u is 3x take 2 in brackets. And we're told it's u to the power of 4, so it'll be 3x take 2 in brackets to the power of 4. That is the derivative. That is your answer. Let's try that one more time. So we're going to differentiate the following. So let's let u equal. So I'm going to let u equal 3x squared plus 4x take 1, which means du over dx equals 3x squared. 2 3s are 6, you get 6x plus 1 times 4, 4. That's du dx. I also have y equals, I'm rewriting the question here, instead of putting 3x squared plus 4x take 1, I'm going to call that u, so it's y equals u to the power of 12. Which means dy over du equals 12 u to the power of 11. So let's actually differentiate this now. So the original derivative, dy dx is the derivative we were looking for because there were x's in it, is dy over du times du over dx, which equals, now dy over du, that's 12u to the power of 11. Du over dx, that's 6x plus 4. Because there's two parts there, I'll keep it in a bracket. Now, what's another way of writing u? Well, u is in fact 3x squared plus 4x take 1. So it becomes 3 x squared plus 4x take 1 to the power of 11 times 6x plus 4. Now that's probably good enough, but if you look at this bracket here, it's got a common denominator, or common factor, denominator. Common factor, 2 goes into 6, 2 goes into 4. So I'm going to take out 2 as a common factor, and if I put 2 as a common factor out the front, it's going to times to the 12 that's already there, and 2 times 12 is 24. And because I took out 2 as a common factor, 2 goes into 6 3 times, 2 goes into 4 twice. There's your final answer. Now, I could do the same with question 3. I could say, let's let u equal 4 take x. So du dx equals minus 1. Y equals the square root of u, because 4 take x is u. Y equals u to the power of a half. I can't differentiate it like this, and we haven't done fractional powers yet. So I might just skip this one for the moment. Oh, actually, I'll go through it, but we will go over how to differentiate square roots and cube roots later. If I look at this, the process is the same. dy over du equals, you take that power and times it to the number at the front. Half times the 1 in front is a half. Decrease the power by 1, half take away 1 is minus a half, and we stop. So, dy over dx equals dy du times du dx. dy du is a half u to the minus a half. du dx is minus 1, which becomes a half times, now u is 4 take x, to the minus a half, times minus 1, so I'll just put a minus out the front, and that will do there. That's your derivative. Now that process is messy. We want to shortcut it, and this is the shortcut. The shortcut says, if you've got a bracket to a power, this is the rule, the derivative is equal to the power multiplied by the derivative of your bracket, and then rewrite your bracket and decrease the power by 1. That's the shortcut. If we could use that, that's so much faster. So let's look at this. The derivative of differentiating 6x, take 1 in brackets to the power of 11, the derivative equals. Now, you write down the power. Because the power is 11, you just write that down, or times it to the number at the front of the bracket. 11 times 1 is 11. Times the derivative of the bracket. The derivative of the bracket. 6x take 1 is inside the bracket. What's the derivative of 6x take 1? 6. Then you rewrite the bracket, decrease the power by 1. There's your answer. That's much faster than using dy over du times du over dx. Let's try it a few more times. Let's try this one. The derivative equals, the power is 5. 5 multiplies to the number in front of the bracket, so 5 times 1 is 5 times. Focus on your bracket. What's the derivative of 3x plus 7? It's 3. Then you rewrite the bracket, decrease the power by 1. Much faster than dy over du times du over dx. That's your answer. Find d dx of the following. That means find the derivative. Now you can't differentiate when that's on the bottom, so I'm going to rewrite it as y equals, and I'm going to move the 3x take 2 up to the top. So I've taken this 3x take 2 cubed and moved it up to the top, which means it's going to become a 3x take 2 in brackets to the power of minus 3. But now I can differentiate it. So differentiating this, the power gets multiplied to the number out the front. Minus 3 times the 1 out the front is minus 3 times. the derivative of the inside of the brackets. The derivative of the inside of the brackets. Derivative of 3x take 2 is 3. Rewrite the bracket. Take 1 off the power. And there's your answer. Now you could take that one step further using indices and move that back down to the bottom so we don't have a negative power and we have a positive power because the question was written in that form, so we return it back to that form. Let's try number 7. So the derivative equals the power gets multiplied to the number in front of the bracket. I haven't had numbers in front of the brackets, but if they were there, they'd be times by the power. So 9 times the 1 is 9. The derivative of the bracket, derivative of 4x cubed, is 12x squared. The derivative of 7x is 7. Because there's 2 parts, I better put that in brackets. Then I rewrite the bracket, decrease the power by 1. There's my answer. Finished. Don't need that times in front of them between the 9 and the bracket, but that's it. Done. Much faster than dy over du times du over dx. Okay, question 8 is talking about parametrics. Now, parametrics involve x and y, but also a t, and we'll talk more about parametrics in detail later. But for the moment, we're told x is equal to t squared and y is equal to 2t. So where we have a point, the point t, the x value is replaced with a t squared, and the y value is replaced with a 2t. If you want to differentiate, the derivative of y with respect to x is differentiate y with respect to t and differentiate x with respect to t and divide them. And we are asked to differentiate, so let's do that. We start by saying if x equals t squared, dx over dt will equal 2t, because the derivative of t squared is 2t. And for the second part, if y equals 2t, then dy dt equals 2. So now we can actually find dy dx, because we're told dy dx equals dy dt over dx dt. That's the formula here. Now dy dt we know is 2. dx dt is 2t. The 2's cancel, so you get the derivative is 1 over t. In part B it says to find the equation of the tangent at t. Well, we know t is at the point t squared comma 2t, and we know it has a gradient of 1 over t. So let's find the equation of the tangent. So we use our normal rule for finding the equation of a line. Y take y1 equals m bracket, x take x1, y take 2t equals 1 over t, x take t squared. I might multiply this t across over here, which gives me ty minus 2t squared equals 1 multiplied by the bracket. Works like that. I'm going to give it in general form. So x is there. I'm going to minus ty to both sides. And I'm going to plus 2t squared. So on a plus of 2t squared, I'll get plus t squared. That's in general form. Part C says to find the x-intercept. Now how do you find an x-intercept? You let y equal 0. So when y equals 0, you get, when I come back down here, so this is the tangent. If I let y equal 0, I get 0 equals x plus t squared. Oops, let's go back to the pen. So I'll get 0 equals x plus t squared, or I'll get x equals minus t squared, which means the x-intercept A is at minus t squared, comma, 0. Part D says to find the midpoint of AT. Well, here's our midpoint formula. The midpoint of A and T is equal to, add the x values, divide by 2, add the two y values, and divide by 2. Well, we're looking at point A and point T. So, point A is there, point T is there. So, add the x values, you've got t squared and minus t squared. That's over 2. Add the y values, 2t and 0. And that will give you t squared, take t squared as nothing, so you get 0, comma, 2t over 2 is just t. And it says, why does the midpoint lie on the y-axis? Well, it's on the y-axis because it has an x value of 0. So it's on the y-axis because it has an x value of 0. Part E says eliminate t to show the curve is y squared equals 4x. Well, what we need to do is go back to the original pieces of information here. We know that x equals t squared, and we know that y equals 2t. The easiest one to arrange in the form t equals is the second one, y equals 2t. I'm going to divide both sides by 2, which means y over 2 equals t. So what we'll do is we'll sub t equals y over 2 into x equals t squared. And if you do that, you get x equals y over 2 in brackets squared. X equals y squared, 2 squared is 4, times the 4 to the other side, 4x equals y squared, or y squared equals 4x, which is what you were looking for. Now, with this last one, suppose y is a function of x and x is a function of t, then blah, blah. That's going to be a real mess. But this is what we're actually trying to do. There is an easier way to do this, but we're going about it in a roundabout way. We're going to square both sides, and it gives you y squared equals x, or x equals y squared. Now I'm going to find dx dy, not dy dx, dx dy, because I've got x and y in the wrong order. So if I differentiate y squared with respect to y, it becomes 2y. And that's the same as 2y over 1. Now I'm going to turn everything upside down. But y is equal to, if I look up here, y is equal to the square root of x. So dy dx equals 1 over 2 square root x. That's what we've actually done. That's what this rule here is saying. It's saying if you find dx dy and turn it upside down, that's the same as it's another way to help you find dy dx. Time for you to try some questions and see how you go. Bye for now.